So, hello again, and finally, we can talk about how we can use limits to explore the behavior of functions. As for example, let's take a look at the limit of e raised to negative x as x approaches infinity. Alright, now to answer this, we need to understand how e raised to negative x looks like. So first, let's see now. If I had an e raised to x, the function, of course, looks like this. Right, and obviously, this is a 0 and a 1. Now, if I had an e raised to negative x, then my function would be a reflection from the y-axis. So since this thing is the y-axis, then my function should look like this. And notice that we know that this x-axis is called the asymptote. And so if you understand this function as it is, as the x approaches a very large value, and let's say it's infinity, and that's what we're doing here, we're trying to understand how this function behaves as x approaches infinity. So according to the graph, the function seems to go very, very close to 0, but not exactly 0. And hence, since that's a definition of a limit, what's the behavior of the function as you approach the value designated in here? And in that case, we observe that, well, the function approximates 0. And hence, the answer to this is 0. So what's the good sense about taking limits as x approaches infinity? It is a really good way to understand how our function behaves as x approaches a very large number. That is the sense of taking the limit as x approaches infinity of any function that we declare. Alright. How about if the function was x squared? So let's try it out. Well, if we observe it, we see that x squared looks like this on the positive side. And as you approach a large number, the y also approach a very large number. And hence the answer to this is also infinity. Which means that for us, as humans, we understand that x squared doesn't have any asymptotes. Compared to e raised to negative x, e raised to negative x has an asymptote, which is equal to the x-axis. Alright, thanks for watching. See you again next time.